Okay, let's take a moment to talk about properties of real numbers. Properties of real numbers are essentially the rules that we use in order to simplify algebraic expressions, combine the terms, simplify the expressions in ways that we can use them and make more use of them. So a property of real number. Well, there are actually 9 of them, and each of them have their own separate names, and we have to know these rules in order to justify any of the steps that we take when we are simplifying algebraic expressions, and we'll go through a few examples of those. But first things first, we talk about rules for addition. Some of the rules for addition are the commutative property. The commutative property states that if we have two numbers added, a plus b, it is the same as b plus a. Well, yes, of course that's true. We know that if we take 3 plus 4, or if we take 4 plus 3, we're going to get 7 either way. The associative property, slightly different, says that if we combine 3 or more numbers together, it doesn't matter by addition. It doesn't matter in what order we take the addition. Which 2 we add first doesn't matter. So for example, a plus the quantity b plus c is the same thing as the quantity a plus b plus c. We don't have to go adding a to b and a to c separately. The identity property tells us about 0 and how it works. Well, essentially, an identity is something that doesn't change, that is an algebraic operation that doesn't change the value of a variable. So adding 0 is the algebraic identity. A plus 0 is equal to itself. The inverse property essentially reverses the position of those numbers in our identity property and says that if you take a number and add its opposite, you'll get 0, the identity. Multiplication has some similar rules. Of course, they go by the same names. The commutative property of multiplication says that if we're multiplying two real numbers, multiplication order doesn't matter. A times b is equal to b times a. The associative property states that if we take any 3 numbers and we multiply them together, it doesn't matter which 2 we choose to multiply together first. A times the quantity b times c is the same as taking a times b times the quantity c. We don't have to distribute. That's a different property. The identity property for multiplication is different this time. We don't multiply by 0 and get a, we multiply by 1. So the multiplicative identity is the number 1. Any number times 1 is itself. The inverse property, again, reverses the operation of multiplication. And in this case, the inverse property says that if we multiply a number by its reciprocal, a times 1 over a, we get 1. The 2 cancel them out. And you should know, of course, 2 times something like 1/2 would equal 1 is a perfect example of that idea. Finally, we have the distributive property, which combines multiplication and addition, and it says that if we multiply a quantity times the sum of two numbers in parentheses, we can distribute that multiplication to both terms in the parentheses. Well, let's go through a few examples of what we mean by that. We do have to define a couple terms. When we say simplify an expression, well, what do we mean? Simplifying an expression is a way of combining terms in such a way. Let's see if I can get that adjusted here. Combining any terms of the expression in such a way that we can combine using the operations of addition, subtraction, multiplication, division, powers, roots, symbols of groupings, parentheses and brackets, and so on, so that we have an expression that is in a simpler form than what we started out with. One of the most basic ways of doing that is combining like terms. How do we combine like terms? Well, like terms, first of all, we have to define what a like term is. And if I can get this thing to cooperate, it'll be a much better day for me and you too. Like terms are parts added or subtracted that have their terms that are added or subtracted that have the same variables, and all of the variables have the same exponents. So for example, The two below are examples of like terms. However, if I happen to have a square, right, if I said, gave you a third example right here, and I said, well, let's combine 2x plus 5x squared, there's nothing else that can be done. They're not like terms. Even though they both contain x, one is squared, the other is not. Can't be combined. Well, let's go through the operations right here. If I said simplify negative 7b plus 4b, how do we combine them? Well, we combine like terms by adding or subtracting their coefficients, that is, the numbers multiplied by the variables. We can think of our distributive property to justify this one, by the way, because b is multiplied by each of the two terms, and in fact it is essentially the same as saying negative 7 plus 4 times b by the distributive property, which is the same as saying negative 3b. But we know that negative 7 plus 4 is negative 3, so we often dispense with this step when we're writing or combining our like terms. So for example, if I take 8c minus 9c, I know that I've got 8 of that variable. I'm just taking away 9 of the same variable. That's going to give me a deficit of one of those variables. We would write negative 1c, or very often when we see a 1 in front of a variable, we don't carry it. We just write negative c as the result.